Imagine this. The moon, that cold, lifeless rock in the sky, might be hiding one of the most futuristic materials known to science. Graphene. And not some lab-created stuff either. We're talking about naturally occurring graphene, formed without human hands. Discovered not in some fancy clean room, but buried in a handful of lunar dust scooped up by a robot. This changes everything. Here's the kicker. Graphene is a one-atom thick sheet of carbon atoms arranged in a honeycomb lattice. It's outrageously strong, 200 times tougher than steel, and conducts electricity better than copper. So far, making it on Earth requires special labs and lots of money. But if we can find it on the moon, that flips the entire conversation about lunar resources on its head. This all started when China's Chang'e 5 mission brought back a small payload of lunar soil. Nothing fancy, just under 4 pounds of dirt. But inside that tiny batch, researchers found something extraordinary. Ultra-thin carbon layers that looked almost exactly like multi-layer graphene. And they didn't just guess. They ran the data through lasers, microscopes, and spectral analysis. Every test confirmed it. This wasn't some fluke. The moon somehow made graphene. That discovery didn't just surprise scientists. It shook up our whole understanding of the moon's past. Until recently, it was assumed that the moon lacked much carbon, probably because its birth was so violent. The dormant theory says a Mars-sized object smashed into Earth billions of years ago, and the debris eventually clumped into our moon. The heat? That violence? It should have vaporized most volatile elements, including carbon. But now, that theory's under pressure. Because if natural graphene, a delicate structure of carbon, exists in young lunar rocks, then carbon had to either survive the crash or get added later. And it wasn't just a trace amount. The spectral signature suggests clean, orderly layers like the kind grown in Earth's most high-tech facilities. Let's talk conditions. The moon is a brutal place. No atmosphere. Constant bombardment by solar wind, charged particles from the sun zooming in at hundreds of kilometers per second. They slam into the surface, breaking chemical bonds, sputtering atoms into space, and occasionally flash heating lunar soil to thousands of degrees. It's like a cosmic sandblaster. And yet, those chaotic conditions may be exactly what forged the graphene. According to the research team, it likely started with solar wind carrying bits of carbon across the lunar surface. When those atoms hit iron-rich grains in the dust, the metal may have acted like a catalyst, kickstarting the formation of carbon layers. Brief heating events may be caused by ancient micrometeorite impacts or leftover volcanic warmth could have created the perfect environment for graphene to grow, one atom-thick layer at a time. What's wild is that the graphene doesn't form easily. On Earth, we need vacuum chambers, high temperatures, and precise conditions. But on the moon, nature might be doing it for free. Even more fascinating, the same soil samples contained trace amounts of other elements, nitrogen, sulfur, and molybdenum, suggesting a cocktail of reactions taking place over time. These aren't the leftovers of a single explosion. They're a geological diary written in atoms, each layer preserving a piece of lunar history. So, what does this mean? First, the moon may not be the dry, boring rock we once assumed. If carbon is present in usable forms, that changes everything for future missions. Astronauts and engineers wouldn't be walking on dust, they'd be standing on raw materials that could be turned into structures, electronics, and even breathable air. Think about that for a second. Future moon bases might print their own components from lunar graphene. Power systems, water filters, radiation shields, all built using what's already up there. It's not science fiction. It's just smart logistics. And here's the kicker. Graphene isn't just strong and conductive, it's also incredibly light. That means rockets wouldn't have to haul as much weight from Earth. Everything from construction panels to life support membranes could be made locally, saving billions. This discovery also opens the door to a new kind of space prospecting. Instead of hunting for gold or platinum, future missions might scan for graphene-rich regions. And because the carbon seems to bond with iron particles, scientists are already imagining ways to extract it using magnetic fields or sonic vibrations. No shovels, no bulldozers, just smart, efficient harvesting. But zoom out for a moment. The real story isn't just about graphene, it's about rewriting what we thought we knew. For decades, textbooks and mission plans have been based on assumptions that the moon is dry, that it's carbon-poor, that its surface is static and dead. But this discovery cracks that foundation wide open. Maybe the moon has been chemically active for longer than we realized. Maybe it's still evolving. Some researchers are even questioning the original impact theory altogether. If carbon survived in such fine structure, maybe the collision wasn't as fiery as we imagine. Or maybe the moon formed differently, slowly accreting from cooler material within Earth's orbit. Either way, we're no longer looking at a finished story. We're reading the first few chapters of something far more complex. And let's not forget the practical ripple effect. The more we learn about how nature assembles graphene in hostile environments, the better we can mimic that process back on Earth. If lunar dust can teach us to make graphene cheaply and cleanly, it could revolutionize industries from tech to medicine. Flexible displays, ultra-fast electronics, advanced batteries, all could benefit from a moon-borne breakthrough. But we're just scratching the surface, literally. Chang'e 5 only collected dust from the top layer of the moon. We have no idea what's buried deeper. Future missions that dig below the surface could find thicker graphene veins or even entirely new carbon structures, shaped by pressures and temperatures we haven't even imagined. And here's where it gets thrilling. We might be on the edge of a new space race, but this time, it's not for territory. It's for knowledge, for materials, for the secrets hidden in the alien soil. Countries and companies alike are now eyeing the moon not as a destination, but as a source. And graphene might just be the first clue that it's worth the trip. One thing's clear, the moon isn't done surprising us. And with each grain of dust, it's whispering a story we've only just begun to hear.
The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese Lunar Orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the Moon, leaving craters as a reminder of this collision. If you're standing on the surface of the Moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile wide asteroid and its 1-mile wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, The temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night. And suddenly, there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon. But then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has two cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon being in the shape of a horn, begin to split in two from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the SOFIA telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the moon. These places have never seen light, and the water there might be encased in ice. But SOFIA found water on the sunlit surface of the moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the moon. But an even more unusual phenomenon is happening there right now. The moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true.
The moon has always been a source of wonder, myth, and mystery. It lights up our nights, controls the tides, and marks the rhythms of time. But what if the moon isn't what it seems? What if this familiar, glowing orb in the sky is not a natural object at all, but a hollow, perhaps even artificial construct? That's the central idea behind the hollow moon theory. A concept that blends science fiction with ancient lore, and dares to question everything we think we know about Earth's closest celestial neighbor. Let's explore the bizarre clues and strange stories that fuel this unsettling possibility. During the Apollo missions in the late 1960s and early 1970s, NASA astronauts left behind scientific instruments, including seismometers. In 1969, the Apollo 12 crew intentionally crashed a portion of their spacecraft onto the lunar surface. The result shocked mission control. The moon reverberated for over 50 minutes. Scientists said it rang like a bell. This was not a one-time event. Later impacts during Apollo 13 and 14 produced similar results. Long-lasting, deep seismic vibrations that were unlike anything observed on Earth. Some theorists argue that this behavior could be a sign that the moon is hollow or has vast inner cavities. After all, nothing on Earth behaves that way unless it's mostly empty inside. NASA's explanation is more conservative. The moon has a dry, rigid crust with little water content, which allows seismic waves to travel much farther than they would through Earth's moist, fractured interior. Still, the Bell effect remains one of the strangest lunar anomalies on record. In many ancient cultures, there are legends of a time when there was no moon. Aristotle mentioned that the Pelasgians, the ancient people of Arcadia, lived before there was a moon in the heavens. The Zulu people of Africa tell stories of 2 brothers, Wawane and Mpanku, who brought the moon to Earth, an artificial object, hollow and controlled, which changed the weather and caused great floods. Ancient Sumerian texts also hint at a celestial object that arrived unexpectedly in the sky. These accounts span multiple continents and civilizations, alluding to a world that once turned without a moon. Are these myths simply poetic metaphors? Or could they be distant memories of real events passed down in the only language available to ancient humans, myth and story? The moon is the 5th largest natural satellite in the solar system, and by far the largest relative to the size of its planet. No other moon comes close in size ratio. This alone makes Earth's moon an outlier, but there's more. The moon is precisely the right distance from Earth, about 384,000 kilometers, to perfectly cover the sun during a total solar eclipse. The sun is 400 times larger than the moon, and also about 400 times farther away. This perfect 400 to 400 ratio creates an extraordinary visual phenomenon that allows scientists to study the sun's corona during eclipses. Coincidence? Maybe. But to some researchers, it feels more like design. And then there's the moon's orbit. It's almost perfectly circular, and it's tidally locked, meaning we always see the same face. We never see the far side of the moon from Earth, unless we send spacecraft around it. Why does this object behave so precisely? Is it a natural product of gravitational forces, or something else? In 1970, Soviet scientists Mikhail Vasin and Alexander Sherbakov published a radical paper titled, "Is the Moon the Creation of Alien Intelligence?" They suggested that the moon may be a colossal, ancient spaceship, an alien construct disguised as a natural satellite. According to their hypothesis, the moon might have a metallic outer shell with an inner structure that once supported machinery, life, or monitoring equipment. They compared it to a planet-sized arc that could travel between star systems. While their paper was largely dismissed in the West, it planted the seed for countless other theories. Could the moon be a derelict alien spacecraft? Long abandoned, perhaps watching us still? More recent fringe thinkers have proposed even stranger ideas. Some argue that the moon might not just be a passive structure, but a kind of anchor for a simulated or controlled reality. In this vision, the moon is not just hollow, but alive with technology, possibly operating as a monitoring station, memory regulator, or even a civilization reset button. Ancient floods, magnetic pole shifts, and unexplained disasters. Some theorists claim these events correlate with specific lunar alignments or cycles. Others go further, suggesting that the moon is part of a larger system designed to keep human consciousness limited, trapped in cycles of forgetting and rediscovery. Is the moon helping to shape our very perception of time, reality, and evolution? It's impossible to prove, and perhaps that's the point. Even beyond the big theories, there are many small puzzles that don't quite fit. For example, when scientists first studied moon rocks, they expected to find thick layers of accumulated dust, possibly several meters deep. Instead, the moon's surface dust was surprisingly shallow. Where did all the debris go? Radio signals sent to the moon sometimes bounce back with strange delays, suggesting interior reflections that aren't typical for solid rock. And then there are the mysterious transient lunar phenomena. Sudden flashes, glows, or color changes on the moon's surface. These have been observed by astronomers for centuries, yet remain unexplained. Mainstream science sees the moon as the product of a massive collision in Earth's early history, a fragment of the young planet that cooled into orbit. But for every answer science provides, there seem to be more questions. Why does this object behave so perfectly? Why do myths around the world speak of its arrival? And why does its presence feel so scripted? Whether you believe in the hollow moon theory or not, one thing is certain: the moon is far more than just a rock in the sky. It is a mirror to our imagination, a beacon to our ancestors, and maybe, just maybe, a puzzle we were never meant to solve.
Count how many times the word moon is said in this video. Enjoy. There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonates, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't submoons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile wide submoon could only survive moving around a 600-mile wide moon on a wide separation orbit. If these parameters are not met, the tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic, galaxy-sized black holes.
It was a warm morning in Siberia, June 30th, 1908. Suddenly, a bright flash illuminated the sky. It was an event no one could explain for decades. The Tunguska explosion, one of the most mysterious disasters to have ever occurred on Earth. It could have been an asteroid crash, like the one that destroyed dinosaurs millions of years ago. But for one creepy fact, there was no impact crater. The event itself happened in the vast forests of northern Siberia, over the Podkamennaya Tunguska River. The blast was so insanely powerful that it leveled about 80 million trees across a massive area of 830 square miles. What phenomenon could have had such an immense force? No one could understand it. Thousands of animals lost their lives and the ground lay scorched. Witnesses saw glowing skies and something they described as a fireball, a bluish light brighter than the sun that had streaked across the sky. Seconds later, there was a flash and a sound like artillery fire. The shockwave shattered windows hundreds of miles away. People felt the blast's force, getting knocked off their feet from afar. For years, scientists puzzled over what exactly had happened. As I've already mentioned, weirdly, the area had no impact crater. But the damage and eyewitness reports left no doubt that something immense and horrifying had occurred. This bizarre lack of evidence resulted in wild theories. Some people suggested it was an alien spacecraft that had crashed in the region. Others speculated it might have been a mini black hole or antimatter particle. There was also an idea that about 10 million tons of natural gas had leaked from deep in Earth's crust. This gas rose into the atmosphere and drifted along like a giant invisible wick. Eventually, there was a spark, maybe lightning, which set it on fire. The flames traveled down the wick of gas back to its source on the ground, causing a huge explosion. But this idea didn't get very popular. Which theory was true? Scientists couldn't agree on one and were in doubt. To add to the mystery, the impact area was incredibly difficult to reach. It took almost 2 decades before scientists could investigate that remote site. In 1927, scientist Leonid Kulik brought an expedition there. They did their best to investigate the region and find the long-awaited answers, but they found nothing. No meteorite fragments, no crater, just millions of fallen trees and slowly disappearing signs of total devastation. The mystery began to clear when a similar event occurred over a century later. On February 15, 2013, the Chelyabinsk meteor exploded in an airburst over Chelyabinsk, around 1,500 miles west of Tunguska. This time, many people witnessed and recorded the event on video, which gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely a large asteroid about the size of a 5-story building, exploding around 15 miles above ground. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause damage on the same scale as Tunguska. Now imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up. All of a sudden, it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. Since this explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface with enormous, incomparable force. The Standard Model physics is our best explanation of how tiny particles and forces work. But sadly, it doesn't show us the full story. There are still some great mysteries it just doesn't solve, like why we have gravity, what dark matter is, and why there's so much more matter than antimatter in the universe. Plus, the Standard Model doesn't work with Einstein's theory of gravity, which makes things weird near black holes or the Big Bang. What I mean is the Standard Model doesn't explain gravity, which is actually a massive deal. We can't just toss in a graviton particle and call it a day because this model and Einstein's gravity don't get along. They each work great on their own, but not together, especially in extreme spots like black holes or at the start of the universe. Right now, particles are seen as tiny excitations in fields, known as quanta, described by quantum field theory. But calculations often produce nonsensical infinities. To handle this, we replace these infinities with measurable values, making the theory work in the real world. This process is called renormalization. When it comes to gravity, though, things get complicated. Trying the same method for gravity leads to an infinite number of these infinities, requiring endless experiments to fix them, which is an impossible task. This makes gravity non-renormalizable, so we can't fit a gravity particle or graviton into the Standard Model. Then, we should remember that particles behave differently depending on their energy level. To study them at higher energies, we first have to accelerate them to those levels. Right now, the highest particle energies we can reach are at CERN. So, the Standard Model is mainly designed to explain what we see in experiments there, but we can't be sure it holds true at even higher energies. In fact, there are clues suggesting that the Standard Model might start to break down beyond the energies we can currently achieve. Plus, the Standard Model explains around 5% of the universe's stuff, what about the other 95%? That's where dark matter and dark energy come in. Dark matter behaves like normal matter, but is totally invisible, while dark energy acts like a mysterious anti-gravity force, pushing the universe to expand faster. Then we have neutrinos. They should have no mass according to the standard model, but they actually change types or oscillate in a way that suggests that they do have mass. Scientists simplified things by setting neutrino mass to 0 in the model. And this doesn't impact CERN's results since neutrino masses are extremely small. Finally, our universe is made mostly of matter, yet the standard model says that matter and antimatter should have been created equally. So why don't we have a balanced mix of both? Scientists call these gaps beyond the standard model physics. We'll call it BSM physics. This is where things get exciting because physicists are exploring all sorts of ways to expand the standard model with ideas like new exotic particles or hidden forces we haven't discovered yet. And recently, CERN's NA62 experiment has announced a big discovery that might help us finally find BSM physics. They observed a super rare kaon decay where a positively charged kaon decays into a pion and a neutrino-antineutrino pair. How rare is this process? It happens in less than 1 in 10 billion kaon decays. This level of rarity makes it the perfect place to search for even the smallest deviations from the standard model predictions. This process had been seen before in past experiments. But this time, NA62 hit the 5 sigma mark. It's a level of certainty that's considered a real discovery in physics. But why is this kaon decay so important? Physicists track rare decays because they act like sensitive detectors for hidden physics. The standard model makes specific predictions about how often these decays should occur. If the measured decay rate doesn't match the predictions of this model, that's a big clue there could be some hidden physics lurking in the background. NA62's latest measurement of the kaon decay rate was about 50% higher than what the standard model predicts. This difference is still within the margin of error, but raises an eyebrow or two. Obviously, more data from the experiment will help clarify whether this difference means new physics or just random chance. By the way, making this discovery wasn't easy. The NA62 team created kaons by blasting a high-intensity proton beam into a stationary target, generating nearly 1 billion secondary particles per second. Out of these, around 6% were positively charged kaons. The researchers carefully tracked those kaons with their detector to record the decay products. From 2016 to 2022, NA62 collected data and upgraded its detector, boosting its beam intensity by 30%. Such upgrades were crucial. They helped with filtering out background noise and distinguishing those ultra-rare decays from the billions of others. With more data rolling in, NA62 hopes to push the boundaries even further. Physicists are excited to see if this kaon decay might really be hiding some BSM physics. It's all about spotting tiny blips that hint at something new and groundbreaking in the universe. Look at these bizarre bright patches on the surface of Ceres, a dwarf planet in the main asteroid belt between the orbits of Jupiter and Mars. Scientists have been wondering about the origin of these spots for a long time, and the mystery is finally solved. But first thing first, we must speak about NASA's Dawn mission. It was launched to give us up-close views of 2 celestial bodies, giant asteroid Vesta and dwarf planet Ceres. This spacecraft uses special ion engines, not regular chemical ones. They produce less power but can run for a long time, which makes Dawn faster over time without needing as much fuel. In 4 days, the engines can increase speed by about 60 miles per hour. By the time Dawn wrapped up its mission in October 2018, it was flying a mere 22 miles above the surface of Ceres, practically hugging the planet. Thanks to that, we got a few incredibly sharp images of these mysterious bright spots on Ceres. Even before Dawn arrived in 2015, telescopes had already spotted those shiny patches, but no one knew what they were. From orbit, Dawn snapped high-resolution images of those reflective areas, especially 2 bright ones inside Ocketer crater. After a lot of detective work, scientists figured out that those areas were mostly made up of sodium carbonate, a compound made of sodium, carbon, and oxygen. In other words, salt. But it wasn't just any old salt. It likely came from the liquid that had risen up from within Ceres and evaporated, leaving behind a shiny salt crust. And that's where things get exciting. Dawn got closer and closer to Ceres, which allowed astronomers to figure out that the liquid responsible for the bright patches came from an underground reservoir of brine or salty water. This briny reservoir is massive, stretching about 25 miles deep and hundreds of miles wide. And since Ceres isn't like icy moons orbiting big planets, where gravitational pull causes internal heating, it manages to keep liquid deep beneath its surface all by itself. One of the most intriguing areas of Ceres is Occitor Crater, a massive 57-mile wide depression that houses the brightest spots on the planet. This crater became one of the main goals of Dawn's extended mission. The spacecraft not only confirmed that these bright regions were young, some less than 2 million years old, but also found evidence that the geologic activity behind those spots could still be ongoing. The thing is, Dawn detected salt compounds in those bright areas, including sodium chloride, chemically bound with water and ammonium chloride. Now, salts with water in them tend to dehydrate really fast on the surface in just a few hundred years. But the salts on Ceres still had water in them, so the liquids must have reached the surface very recently. This discovery is proof that liquid is still flowing from deep inside Ceres up to the surface today. But how does this salty liquid make its way to the surface? Researchers have found two main ways it can happen. When the impact that formed Occitor Crater occurred about 20 million years ago, it melted a layer just beneath the surface. That slushy layer held a bunch of salts that gradually bubbled up to the surface. The impact heat subsided a few million years later, but large fractures left behind allowed briny liquids to continue seeping up to the surface from the deep underground reservoir. So even though the heat was long gone, the crater remained active because of those giant cracks. But Dawn didn't just find evidence of recent liquid activity through these bright patches. It also discovered something that looks a lot like Pingo's small, conical hills found in Earth's polar regions, formed by pressurized groundwater pushing up and freezing. Before, scientists have also seen Pingos on Mars, but spotting them on Ceres was a first for a dwarf planet. This is another clue that there's still liquid moving around under Ceres' surface. It means that Ceres is way more active than we thought. There's salty water beneath the surface and geologic activity that's most likely still happening. The mysterious bright spots, which are the result of liquid making its way up through fractures in the surface. And let's not forget about potential Pingos. It's clear that Ceres, even though it's just a dwarf planet, is a dynamic world, much like the icy moons we see elsewhere in the solar system. Look at this. Cosmic particles from all over the universe are constantly flying through space. These high-energy particles, moving almost at the speed of light, are known as cosmic rays. When they collide with our atmosphere, they produce showers of new particles, and some of them reach Earth's surface. What particles do you know? People usually remember protons and electrons, which are all around us because they are stable. They cannot decay. In reality, there are a lot of other known elementary particles, but they are not stable and decay after some time. Among these particles are muons, which, by the way, were discovered at the beginning of the 20th century while people were studying cosmic rays. These particles are 200 times heavier than an electron, so they decay very, very quickly. They only live for 2.2 microseconds before decaying. This is such a short period of time that during it, light travels less than half a mile. That's why it seems that if muons appear from cosmic rays in the atmosphere, we will not be able to see them, but this is not so. Thanks to time dilation within Einstein's theory of relativity, they can survive long enough to make it down to the surface and even pass through your body. Now on Earth, you're constantly interacting with the atoms and molecules in the atmosphere, as well as photons, which are particles of light. Some of these particles are so energetic that they knock electrons off atoms and molecules, creating free electrons and ions that can strike you too. Neutrinos and antineutrinos also pass through your body. Those are tiny subatomic particles, nicknamed ghost particles because they barely interact with anything else. And still, neutrinos are the most common particles in the universe, with approximately 100 trillion neutrinos passing through your body every second. Luckily, these impacts are so weak that we don't notice them at all. Only special neutrino detectors, worth millions of dollars and larger than football fields, can detect rare single neutrinos. Subatomic particles are normally invisible to the human eye. It can only see light. Quite a long time ago, people realized that we could use some kind of substance which, due to the interaction with particles, emitted the light we could see. In other words, we can create a chamber filled with 100% alcohol vapor. Charged particles passing through it will leave a visible trail, turning your eyes into particle detectors. The thing is, when a charged particle moves through alcohol vapor, it ionizes a path, which then condenses into alcohol droplets. The trail left behind is long enough and lasts long enough for your eyes to see it. The speed and curve of the trail can even reveal the type of particle you're looking at. You can also place a camera in a magnetic field. The tracks become curved, and by their curvature, you can tell something about the particle. All because the trajectory of motion in a magnetic field depends on the mass and charge of the particle. And the good news is, building a cloud chamber yourself is not too difficult. You can easily find the needed materials, and your very own particle detector will cost you less than $100. Here's how you can build a cloud chamber. Start with a rectangular aquarium or fish tank with sealed edges to prevent leaks. Cut 3 pieces of thick insulating foam to fit the tank, 2 with rectangular cutouts for the tank and 1 solid piece for the base. Cut a piece of galvanized steel the same size as the foam and cover it with black cardstock, felt, or matte black paint for better visibility inside the chamber. Now, place the metal plate between the top foam layers and seal it with modeling clay. Add water or alcohol to the groove to ensure no air gets inside the chamber. Modify the fish tank by adding a felt or sponge layer at the base, which will absorb the alcohol. Then, secure the tank well because it will be placed upside down. Once that's set, you can assemble everything. Now place some dry ice in the bottom foam layers, then the metal plate, black side up, and finally, the last foam layer. Pour alcohol into the clay groove while soaking the felt or sponge with more alcohol. Flip the fish tank over and seal it into the metal grooves, creating an airtight chamber with alcohol vapor inside. Next, turn off all the lights in the room and shine a bright flashlight or projector through the tank. To get the best results, put a warm object like a towel fresh out of the dryer on top of the tank. Wait for about 10 minutes, and you'll be ready to see particles in action. To check if your cloud chamber is working, take apart an old smoke detector and remove the metal mantle inside. This component contains radioactive materials, most often americium-241. Place this mantle at the bottom of your cloud chamber once it's active, and you'll see particles shooting off in all directions, leaving trails in the vapor. Americium decays by emitting alpha particles, which are made up of 2 protons and 2 neutrons, basically a helium-4 nucleus. These particles have a low energy and high mass, creating slow, curved tracks in the chamber. Sometimes you can even see them bounce off the chamber's bottom. This is an easy test to ensure your cloud chamber is functioning properly. But alpha particle tracks aren't the only things you can see. Even if you leave the chamber empty without any radioactive source inside, you'll still see straight vertical tracks. These come from cosmic rays. Most cosmic rays are protons traveling at high speeds and energies. When they hit the upper atmosphere, they produce other particles like protons, electrons, photons, and unstable particles, such as pions. If you were to calculate how far a muon could travel based on its lifetime and the speed of light, it would only be able to travel for about 2,160 feet. Obviously, that's far less than the average 100 miles needed to reach the ground from the upper atmosphere. So, why do we see them at all in our cloud chamber? That's where relativity comes into play. Muons are created high in the atmosphere and move at speeds close to the speed of light. From our perspective, time slows down for muons, so they live longer than expected. In their reference frame, distances shrink, meaning the 100-mile journey to Earth's surface appears much shorter. Because of this, muons survive long enough to make it all the way down to the ground. This is relativity in action. From the muon's point of view, it travels only a short distance in its 2.2 microsecond lifetime. Meanwhile, from our perspective, we see it travel 100 miles over 4.5 milliseconds. The time dilation caused by the muon's high speed allows it to live longer and cover greater distances than it could otherwise. So, thanks to Einstein's theory of relativity, muons created in the upper atmosphere can live long enough to reach us here on Earth. That's why even right now, muons are passing through your body every second. Hold out your hand toward the sky, and 1 muon per second will pass through it. Relativity makes this possible. If you've ever doubted relativity, it's understandable. This concept seems kind of counterintuitive and outside of your everyday experience. But with just a few things and a little effort, you can build a cloud chamber and see the effects of relativity yourself. You'll observe muons, see their paths bend in a magnetic field, and even catch some decaying in midair. Their high speeds prove that relativity is real. Without being so swift, these muons wouldn't survive their journey to Earth at all. time dilation and length contraction are real, and the fact that we can detect muons at Earth's surface is proof of that. Traveling in time appeared in many sci-fi movies, but every law of physics claims that the only way we can move through time is forward. Well, thanks to some very exciting properties of space and time in Einstein's general relativity, going back in time seems to be possible after all. According to Einstein, space and time are not separate entities. They're woven together in the fabric of space-time. There's also a quantity that generalizes the concept of distance into 4 dimensions, the space-time interval. It takes into account distance in time. In other words, if you're resting, your spatial position doesn't change and you're moving through time forward at 1 second per second. But if you're moving and your spatial position changes, you travel through time more slowly. All because objects in relative motion experience something known as time dilation. Roughly speaking, the faster you travel through space, the more slowly you move through time. More precisely, time dilation is the difference in elapsed time as measured by 2 clocks because of a relative velocity between them. The faster the relative velocity, the greater the time dilation between them, with time slowing to a stop as 1 clock approaches the speed of light. However, keep in mind that we only know about massless objects, such as photons, that travel at the speed of light. Theoretically, if you could move faster than the speed of light, you'd become a tachyon, a hypothetical particle that always travels faster than light. Also, there is the energy-momentum relation that connects energy, momentum, and mass. One can see from that relation that if a particle moves faster than speed of light, then its mass is imaginary. So, this possibility is an unphysical situation, since tachyons don't correspond to anything that exists in our physical reality. However, Einstein thought that going faster than the speed of light wasn't the only way to travel backward in time. Space-time might not be flat and unchanging. It can be curved, can contract and expand, and can even create and maintain a connection between 2 different points within it. This possibility is known as an Einstein-Rosen bridge. If you jumped into one point and your friend jumped into the other, you could meet somewhere in the middle. At the same time, this tunnel wouldn't be passed through, and you wouldn't be able to get out on the other side. Now, try to imagine space-time as a 2-dimensional sheet of paper. If you fold it, 2 points that were previously separated will become connected in this new 2-dimensional world. This property of space-time might be the most important concept of time travel. You probably know this concept under the name of a wormhole. And it's tightly linked to black holes, regions of space containing so much matter and energy that any light emitted from that region, as well as any matter and radiation that falls there, will never escape. And it doesn't matter how much energy it has or how fast it's moving, even if it's the speed of light. Usually, it's assumed that black holes only lead to a central singularity, and if you fall behind the event horizon, also known as the point of no return, there's nothing but destruction awaiting you. But how about another possibility? What if black holes could actually transport you to another universe? Then, you would be expelled on the other side through something called a white hole, a time-reversed solution of a black hole. But so far, all this sci-fi theory is just a hypothesis. What we do know is that minuscule quantum fluctuations exist in our known universe. They occur throughout the fabric of space-time, most prominently on the tiniest of scales. Such energy fluctuations can occur very close to one another. They are most likely random and often include disconnections and reconnections from the original positive and negative states that initially occur together. If you somehow connected such positive and negative curvature regions together, you could get close to the notion of a quantum wormhole. And if such a wormhole remained intact for a long enough period of time, you could transport a particle through it. In other words, it'd instantly disappear from one location in space-time and reappear in another. But why is a wormhole so crucial when we talk about time travel? Because once you create 2 ends of a wormhole and maintain the connection between them with sufficient mass and energy, this connection will remain eternally. And since this is great for instantaneous travel through space, Probably we could extend it to traveling through time too. Sadly, at the moment, it's just wishful thinking.